Yes, welcome to Vision Plus. My name is Wow Chemist. Today we are going to talk about carbonyl compounds. So far, we are, let's say, we are almost getting done with organic chemistry. So let's look at what we call the carbonyl compounds. And when we want to look at this thing critically, we need to understand them is that we need to look back at what we call al alkanes. Now we say these hydrocarbons are classified into three. And we said we have alkanes, we have alkenes, we have alkynes. When you are just moving, walking, you are going to the market, you've been positioned to say alkanes, alkanes, alkenes, alkynes. Those are the classes of hydrocarbons. But now we are saying most of these organic compounds we are saying they are being derived from alkanes. Sometimes we call them they are called what we call alkanes derivatives. So if they are derivatives of alkanes, then also these carbonyl compounds are also derived from them. Now, when we say carbonyl compounds, this one here they are in two forms. Someone can say they are in two classes. One is what we call the alkanals. Now, so that means here in these alkanes, we have just replaced this E with Al. So therefore here, A, E being replaced by what we call Al. In two forms, we have alkynes, also called, if you don't want to call them alkynes, you can call them aldehydes. We call them aldehydes. Now, then we have another form, we call them alkanoons. So that means, again, in this other form, this E has been replaced by what we call the on. We are not considering this plural form SS. Okay, so if we don't want to call them alkanoons, you'll be in position to call them ketones. Now, after you knowing this thing very well, you'll be in position now to say it. If carbonyl compounds, are divided into two, we have first is what we call the alkynes, aldehydes, alkanoons, ketones. We shall be in position now to see the most important thing here is what we call the general formula. General formula. So what is the general formula for these carbonyl compounds? The general formula is CN2NO. So this is the general formula for carbonyl compound. And this one is the same for alkenoons and alkynes. That's the most important thing. It is the same for alkenoons and alkynes. So if that is the case, now let's see what we call the functional group for these carbonyl compounds. The functional group for these carbonyl compounds is just represented by C, and okay, let me put it like this. It is represented by C, double bond here. Then we have oxygen. So it is represented by this one. Now, we say this one here, they are divided into two. We have alkynes and alkanoons. Now, let's also distinguish their functional group. Now, we can say for alkynes or the aldehydes, we shall put it in this format. It is C. Here we shall have the alkyl group. Then here we shall have something like this. And then from there, we shall attach these two. So the moment I see something like this in organic chemistry, what will come to my mind is that I'm dealing with carbonyl compounds, specifically alkyls or aldehydes. Okay, let's say, how about for alkanoons. How about for alkanoons? For alkanoons, we shall have C and then something of this kind. Then here we have R. We have R. R note represent the alkyl group. This alkyl group is something written as CH2. Okay, let's say CH3, CH2, CH, just the hydrocarbons part of it, of that very molecules. Now, this is the difference. Let's distinguish them clearly. Here, we are saying the H is what? Terminal. So, this H here is at the term, or is the terminal, just at the end of this molecule. Okay, how about here? Here we have the alkyl group attached. But the moment you see something like that, just know I'm dealing with carbonyl compounds. But to be more specific, I'm dealing with alkanoons because of this functional group. Okay, after us knowing this thing very well, what will come to our mind is that this one also, they have their different examples, they have their different chemical reactions. At different conditions, they have different products that they are forming. But now, to be more specific, we shall now start by maybe we shall pick and say we are going to talk about alkanines. We talk about alkanines in detail. Then we pick that one of alkanoons. We talk about them in detail. But all in all, we're in carbonyl compounds. Now, let's take one example. Let's say it, because we have now the general formula. Let's say it, my N is given to be 2. Okay, we say it, for the general formula, it works for all of them. Now, let's say my N is 2. If my N is 2, I will now use this general formula and say it. I have C times 2, then hydrogen 2 times 2, then I attach that. So this one I'll have C2, H4, then something of that kind. This one here, if you have been following, is what we call the molecular formula. It's just showing the number. This one we have oxygen, it is 1, hydrogen 4. Hydrogen atoms are 4, carbon atoms are 4. So this one is just telling us, that this one here, the number is this, is this. And because of that, we're saying this is what we call the molecular formula. Now, some have been positioned to say, what if I come with the condensed formula? I will have something of this kind, CH3, CHO. So this one now is for what? Is for aldehyde, we call the alkanines. Okay, but to be more specific, we shall say we have 2 carbon atoms, 1, 2. So I'll be in position to say E, the name following this, ethanine. So that is ethanine. But we say this functional group also work for the 2 of them. So that means you need to be keen enough in trying to arrange these molecules. So this one I will come up and say it. If this is for alkanines, then this again can be written in another form to bring for us alkanones. So I'll be in position to say I have CH. I'll have CH. For alkanones, we are starting from carbon atom 3. Alkanone N will be 3. Why? Because when we look at the functional group, is that there is carbon atom already. So if there is that one carbon atoms, we shall be in position to say no. Now this time round, we are starting from N is equal to 3. Why? Because there is 1 carbon atoms given, and if I say N is equal to 2, I'll not be in position to get what I'm doing for in alkanones. So let's say N is equal to 3. If N is equal to 3, we shall be in position to say C times 3, H, 2 times 3, then our, okay. Now, if that is the case, we shall say we have C3, C3, then we have the hydrogen atom, 6 of them, and we shall have something of that kind. Now, if this is the case, we shall now put it structural to bring for us alkanones. So here we shall say CH3 or CO, and we shall say CH3. If that one look very awkward, we shall say this is can be written as CH3. Then I put the double bond, put the oxygen there, then I have CH3. Yeah. Now, here, this is what we call propanoons. This naming now is simple for someone who has been following. Now, this one can be written to bring plus propanyl. How? I can say I'll have CH3, CH2, CH2, COH. I'll count the hydrogen atoms. I have 3 plus 2 plus this. I'll have 6 hydrogen atoms. Then I have 1, 2, 3. So this one become propanyl. Now this is just the introductory part. So let's meet in the detail.